and the relationship between the two. That includes actually the AI and robotics trends, how actually this will change the way people manage organizations, and people are managed by other people or by robots, maybe. So it's my great pleasure to have this evening session that concludes, I think, a very good afternoon. Before I leave the floor to Benedict, I'd like also, so first to thank you, everyone, or panelists, for being here, and just to stress the fact that SNO also is a connector across all the different HEC communities. So not just the different professors across departments, the firms that actually finance the center, the students, of course, but also the alumni. And I see that in the room, actually, there are more alumni than students, but it's okay. But just to say that this is basically a connecting thread that links the multiple audiences of the HEC community. So again, thanks to the panelists, thanks for you, and I hope that you will have a very good evening.
Hello, I'm Bénédicte Favre-Tavignot, Executive Director of the SNO Center. I just want to add that this event has been co-organized with the Alumni Association. Thank you, Jeannette and Jeremy. And with the great support of partners of DATAIA and the IDEA Center, which means Innovation, Digital and Entrepreneurship Center at HEC Paris, and of ECODEC. And yes, I would like to give a warm thank to Mitali Banerjee. I think we can applaud obligatory. She's done a huge work in organizing this event, and I keep from you, Mitali, one sentence from this afternoon. As you said, AI can lead to very positive and negative impacts. It depends on the social structures and on the values we decide also to set up. I want to thank also the moderators, so Frédéric Godard, Sang-Suk Yu, and Jérémy Gratadour for this afternoon's panels that all of you, I think, appreciated. And warm thank to Paul-Marie Carfentan, SASI student who has helped us a lot. Thank you, Paul-Marie. And of course, our SNO team, Elisabeth de Réal and Lauriane Toury. Thank you very much. And I leave the floor. Thank you. Where is Elisabeth? Elisabeth is not here. And I leave the floor to Jérémy from the Alumni Association.
Thank you. Good evening. Just a quick word to say that we are very happy to welcome you here in this evening on behalf of HEC Alumni. We are very happy to be associated with this conference, which is all the more beautiful for having been organized, hand in hand with the school. Thank you, Benedict and Rodolphe, and the SNO Center, the Alumni Association, and the students themselves. Why it's so important to engage alumni on this topic? Well, given their professional position, your professional position, you are clearly in a position that you can change the things, have the good decision to help to move forward on action that address the main challenges of our global society. So the subject of this conference fits very well with HEC DNA. Tomorrow is our business. So the presence of HEC full community assembled here today with students, professors, alumni is very encouraging in this sense, and we thank you all for your presence. I will now pass over to Mitali, Professor of Strategy at HEC Paris and Academic Director for this conference. Thank you, everyone, and have a good conference.
Thank you. Thank you very much. So thank you for sticking around. I know it's somewhat of a long evening, and I promise this will be a very interesting panel for all of you. So just a very warm welcome to our panelists who have kindly offered to come here at this somewhat late point in the evening. So just a brief introduction for all of them. To begin with, I'll just go because how they're seated. Mr. Yokos, who is a general manager of Renault Digital and also the vice president of Renault. And he has been with Renault for a long time. He took a break and went to Nissan and then came back to Renault. He has overseen the electric vehicles program, and at this point, he is a key person overseeing the digital transformation of Renault. Mr. Bertrand Urgolio is the CTO and the CSO, the Chief Technology Officer and the Chief Security Officer of Microsoft. He again has been with Microsoft since, I believe, 1991, is that correct?
No, 99, 20 years.
Yes. And he brings a very rich set of experiences to speak about some of the very key issues at the heart of deploying AI within organizations and for customers. Then we have Megan Anslek. Some of you might have heard her in the earlier panel. She is the Chief Analytics Officer of Spencer Stuart, which is an executive search firm headquartered in Chicago. And she is responsible for implementing and designing the algorithms to streamline the executive search process. Megan's past life, she was actually involved in implementing and designing AI algorithms for insurance industries. And we have finally Bertrand Thuillon. He's the director of the DATAIA Institute, and he has himself also been a founder of the NeuroSpin Center, which combines a whole lot of robotics, neuroscience, and AI to develop state-of-the-art research that is deployed in industry, and he's going to tell us more about it. So a very warm welcome to all of you, and we will begin with Mr. Urgolio as our first presenter.
So thank you, Mitali. Thank you for this warm welcome. I understand it's late, so I hope we'll be able to entertain you during this panel. So I'm going to talk a little bit about what's Microsoft's AI strategy and what we are doing in order to implement AI in such a way that it is transforming business and empowering society with AI. So I guess I can use this one? Yes. So in order to support our goal about AI, we are using 3 pillars in order to sustain this goal, which is to empower organization in order to transform industries. So the goal is to use AI in the day-to-day business. In order to do so, we also want to empower developers to innovate through AI. And finally, to empower people to transform society, because we believe that it is very important to support AI in a smooth way in this society where we are going to live in the future. So in order to reach this goal, we have been working on AI since a while. So in fact, if I remember well, we have started to use AI using Bayesian approach in order to filter spams in email in 1997. So it has been a while that we have been using AI to do real tangible stuff. Since then, deep neural net and every transformation around this approach has helped us a lot in order to do some breakthroughs in various domains, especially around vision, computer vision, speech recognition, machine translation, and also being able to understand and comprehend text. On all those domains, we believe that on standard research benchmarks, we have been able to reach human parity for the first time. So we have been focusing on using AI to give computers sensors in such a way that it is possible to use a computer to interact with humans in a better way. We are investing on 3 main areas. AI as a platform, AI as a way to infuse AI on anything we do, every program we write, any service we offer, and certainly in order to implement business solutions. As an example, we have set up our main research lab on ERP and CRM from Paris in order to implement our business solutions for customers. Our platform is mostly based on 3 main domains. Services, which might be pre-trained services, in order, as an example, to use computer vision as a service, or speech recognition, or machine translation as a service. Infrastructure, because we need to have very large infrastructure in order to train and run all the models that we offer to customers, and a very large set of tools in order to allow developers and customers to build their own models if they want. So as far as cognitive services, which are those pre-trained services, we are offering a lot of different services around vision, speech, language, and search. The goal being to enable developers from all their devices through a very easy to use set of services to give their apps a human side. So it might be facial recognition, it might be sentiment analysis, it might be being able to speak and hear from users, being able to implement conversational bots. It is services able to analyze text and extract user feelings and intents, or extracting knowledge from existing sources, and to be able to translate between more than 60 languages and growing. And it is also to be able to use search as a service in a very efficient and fluent way. We are implementing machine learning not only in the cloud, but also on the edge, because we believe that more and more intelligence should be brought to the end user, even on very small devices like Raspberry Pi and objects where decisions have to be taken very near from the user, and basically as the amount of data from which we are able to train our models are more and more real-time and more important, we believe that it is needed to bring intelligence near the data rather than trying to have all the data in a centralized way and learn from those. So this is a combination of cloud and edge computing. So second goal is to infuse AI in everything we do. So it might be within Windows as an operating system, using facial recognition in order to log on, as an example, or to support inking to be able to do written recognition. It might be in order to help developers to very easily use all the various deep learning frameworks which are available everywhere. And it might also be enhancing some applications like this Word demo, which is running in the left, where you can use a resume assistant as an example to write your resume, and knowing that you will be able to rely on LinkedIn as an engine to enhance your resume in such a way that you will be able to match offered jobs on the market. That's an example of something which is freely available today. Beyond everything we do as far as implementing AI, we believe that it is very important to contemplate the fact that AI has to be implemented in such a way that it is usable and acceptable by the society. This is why we have started to work since many years on topics related to ethics and AI, around a lot of different topics like fairness, reliability and safety, privacy and security, inclusiveness, transparency, especially around deep neural net algorithm, and accountability. In order to implement ethics within a very large company like Microsoft, we have established AI and ethics for engineering and research ethics board. This board is composed of 7 subcommittees working on different topics like sensitive usage of AI, AI reliability and safety, human and AI interaction and collaboration, fairness and bias, intelligibility and transparency, especially around AI algorithms, engineering practices for AI, and finally, human attention and cognition. And I'm currently part of this board representing France, knowing that being able to establish ethics in a very large company where you understand that ethics is very much based on culture is very hard, because there are a lot of very different ways of thinking about ethics depending on the culture from you come from. But this is a very important topic where we are able to take decision, especially hard decision, which is potentially to turn down sales when we believe that the project on which we were supposed to work was not compliant with our ethics guidelines. As an example, in this example I'm currently showing, we have decided to turn down a facial recognition project for a government where human rights is not very well respected. We have also implemented a lot of various projects in France, especially about digital skills and AI. You know that in France there is a national civic service which is currently being implemented, and we intend to use this national civic service as a way to train people, especially in schools, through volunteers, on especially AI principles and stakes. And this is something which has been supported by the Secretary of State for Education and Youth, because we believe that knowledge about AI should be spread amongst the entire society, especially for young kids. So the goal is to help them to better understand coding, AI principles, and digital literacy as a whole. We have also created an AI school. This AI school is mostly devoted to people which are usually unemployed, set aside from the society. They usually have some knowledge about computer science, very limited. Our goal is to help them to get to a certain level on AI. This initiative is currently scaled throughout France with the support of a school named Saint-Plon, who has been very efficient to train some people who are usually set aside from the education system and from the employment system. We have also created a think and do tank named Impact AI, whose goal is to have a French-centered view on AI and ethical challenges in order to avoid to have a US-centric view on ethics and AI. This think and do tank has been joined by a lot of different companies, very large, very small, some startups, and also some academics. And the goal of this think and do tank is to anchor AI in the day-to-day projects of companies. So, as an example, we have recently had an event about responsible AI, where we launched a set of tools in order to allow companies and users to potentially create an ethical framework for their own usage, and also to use a lot of different tools in order to, as an example, help them to understand black boxes for algorithm and to potentially detect bias in the way algorithms are being trained. So that's a set of initiatives that we have launched in France in order to enable AI to play a smooth role in the French society. So thanks for your attention, and I welcome your questions afterwards.
So thank you for the invitation to take part to this panel. In my presentation, I'll be giving first an institutional representation of the DATAIA Institute, and then I will take a more concrete example to give you an idea of what kind of partnerships we can build with industry. So the DATAIA Institute is a joint initiative of all the universities and the engineer schools of the plateau to have a common project centered on data science and artificial intelligence. And we decided to collaborate on the basis of four main challenges. The first one is really directed towards AI, so understanding the black box, understanding what happens when you compose different deep architectures, which are so complex, as Bernard already said. The second challenge is more related to data. So how do we exploit the heap of data that we have in many fields now that we collect to get some knowledge from this data, and then also from knowledge to decision. How do we make good decisions based on our data? The third axis is a different view on the data science. It's a view of ethics and transparency, responsible AI, with the concept of loyalty, accountability, etc., which are central to a good use of the data. And this is a concern, a very deep concern for all researchers in AI. Or this is becoming maybe a concern for researchers in AI. And the fourth challenge was more on the human sciences and economy side. So what economical model comes with the development of AI and data science. So overall, these challenges rest on three main pillars. One is mathematics, because you need mathematics to understand deep learning, AI in general. Computer science, because all this is implemented in concrete architecture and with computer science people. And finally, human and social sciences with a part on economy, social sciences and legal sciences, which are all important to make AI acceptable for our society. The application domains, of course, are many because now big data are everywhere. So we have identified, here I give a short list of 6 domains which are particularly important in the plateau, like mobility. We'll talk later about autonomous vehicles, energy and climate, bank and insurance, health and well-being, defense and security, and e-sciences. E-sciences is a bit special to the SACLE area because there are lots of physicists and biologists who generate lots of data and need to analyze them. And so we collaborate with these fundamental sciences. A nice thing with DATAIA, so it's a project funded by the ANR agency, funded for 8 years, which is great because usually in France we have this short-term project and we'll always need to renew them. I think it's good to be able to look forward for a long duration and build long projects. So the main actions of DATAIA. So the idea, general idea is to foster research and training on data science and AI and on the social aspects of these techniques. So of course, we interact with the local partners of the SACLE area, which is, as you know, the main French pole in sciences in general. So the mathematics, computer science, and social sciences doctoral schools. And we also want to have some to help improving the cursus of students by having more crossover between mathematics and computer science, but also more interdisciplinary with more social and human sciences in hard science cursus, so that engineers who will develop the systems of the future become more aware of their responsibility and how to build reliable systems and transparent systems. We fund research projects, so we have decided not to fund small projects, but rather like middle-sized projects, which are about like 200 kilo euros for a couple of labs. So we fund essentially 1 PhD student and 1 postdoc for groups of labs that want to develop jointly some new technologies or work on their application. We also encourage student mobility, whether incoming or outgoing. And we have lots of action for the animation of the ecosystem, which is really the role of an institute like DATAIA. So organizing conferences, workshops, data challenges. So a data challenge is a competition where you pose a problem to people. So you've got some data and you need to predict some outcome based on the data. And so people train their models to solve the task, and then they submit their solution, and we check their solution on left-out data so that we can have a fair account of the winning methods. So we do these kind of things to animate the community and also improve the standards. And we also organize a junior conference and a summer school. Maybe important for you today, we are currently opening an industrial affiliation program. We will open it actually in 1 month, in which it will be a club of industrial partners associated with DATAIA who want to take part to our ecosystem, to our meetings, with whom we will have dedicated meetings on some special topics, like it could be natural language processing, insurance, open system or openness of the system, transparency of the system for strategic decision. So our industrial partners, we have some voice to give on their strategic decisions. So they will take part to our program committee. And of course, we want to foster bilateral collaborations between the industrial partners and the academic partners. A typical example is to organize a CIFRE, a PhD thesis, in which the industrial partner funds a PhD thesis on a given topic, which is done in collaboration with the academic partner. And what happens typically, we've already done that with a couple of partners. What typically happens is that the industrial partners come some more or less precise idea on a system they would like to develop or understand better, and we help them clarify the question first. What can we do for you? and then identify among all the partners of the plateau who will be the best partner for this project. So it's a pretty rich ecosystem overall, which makes it's all its richness. So DATAIA gathers 17 academic institutes, so École Polytechnique, École Centrale, Université Paris Sud, Versailles Saint-Quentin, HEC, of course, and others. It's important to know that all the engineers, the top-level engineers in AI in France have been trained in Saclay because the main masters in data science or AI are in Saclay. So either in École Polytechnique or École Normale of Paris-Saclay. I've also put the logos of some partners with whom we've been in discussions and who might join us for the committee of the industrial partners. And finally, some foreign institutions that you can see here on the right side. So we are developing collaborations with similar institutes, either in the UK, the Alan Turing Institute, in Canada, IVADO, and the JST, the Japan Science and Technology Agency. We just had a workshop together this week in Japan. So the idea is to foster exchange and collaborations between these partners and us. And to make the story a bit more concrete, I would like to switch to a peculiar example. So I'm talking here of a huge ecosystem, so it's hard to give details about everything. So let me narrow down the focus on a small scale project. Actually, it's an open source library, scikit-learn, that I launched with some colleagues 10 years ago. It was my team that did that, and it was a big success. It has become now the second or third most used machine learning library in the world, together with PyTorch and TensorFlow. So these are the tools that people use every day to do some data science task, and we have essentially created the what we call the API, so the standard way to describe machine learning tasks. Now everybody relies on the concepts that we have introduced. So we have users on all the possible platforms and lots of citations. Originally, it was started by people from academia like me, but very quickly it was adopted by industry because we put a very open license system, a free license, a BSD license, to create no barrier for industrial partners to adopt this library. So it's an open source ecosystem. It's a completely open source project where the code can be found online, where anybody can contribute. It's a way to distribute the work across lots of partners. So we've had hundreds of contributors around the world because they were enthusiastic about the project and they wanted to improve it. And so, of course, we had to deal with all these people, and so we did this through an open interface, GitHub, which is a very key object to work jointly on software projects. And sometimes we meet in real life, as you can see here. So a group of geeks working together. And this, as you can see, these meetings in real life boosts our productivity. Of course, the problem of an open source project is how do we develop it in the long term? Because we need to pay engineers to develop it, to maintain the code, to improve it, to fix bugs, etc. So INRIA has supported us a lot, and some academic partners have supported us. But we need now to get to more funding. And from different origins. So for this, we have created this year, just 6 months ago, we created a foundation in which some partners will support us to develop this library. And on the other hand, we will listen to their needs and take them into account for the main directions of developments of the library. So we are not developing for them, that's not the purpose, but we are taking into account their feedback on strategic decisions for the development of the library. So here you can see the members. I'm happy to say that Microsoft is part of it. And so with this, all these partners, we can now pay engineers to go on developing the library. And probably in the long term, because I think all these partners need this library to work well and to remain up to date. Okay, that was it. So thank you for attention.
So I have no slides, so I'm just going to talk to you for a few minutes. I am Megan Anzelk. I head the data and analytics function at Spencer Stewart. As Matali mentioned, it's an executive search and leadership advisory services firm headquartered in Chicago, which is where I'm from, and I'm very happy to be here with all of you. So I thought what I would do is spend a couple of minutes talking to you about some of the experiences that I've had throughout my career, because I'd very much like to hear your questions, and so to just give you a sense of the kinds of things I can perhaps talk to you about. So I am a physicist by background, and then I did analytics and insurance for a decade, and now I work for a search firm. None of those things are related to each other. It's not a trick. But the core skills around critical thinking and computer programming and analysis of data, right? Those all translate across all the different roles that I've had. I've had experience working with very, very large data, huge volumes of data where you really needed sort of edge analytics to really be able to manage it. And then I've worked with itty-bitty tiny data as well. I've worked with structured data and unstructured data. I've worked on analytics projects that were successful and some that were miserable failures, and some that were long, drawn-out, very painful failures. And so I've had experience of coming from academia and then into industry, right? There's certainly differences in those experiences. And then working in insurance, actually applying a lot of these sophisticated statistical techniques, right, that today we call AI, and we didn't used to, we just called them statistics. But applying those to actual real problems, and then monitoring to say, let's actually show business outcomes around that. And in insurance, the predominant ways that's done is through pricing of insurance policies. So if you have cars and homes and renters insurance and things like that, that's all predominantly fully automated behind the scenes. So I help build algorithms that produce the prices for those. But also for commercial and specialty insurance. So insuring this university, the buildings, the people to keep them safe from injury or to get them back to work if they do get injured. All of those as well, that becomes more complex, and it's not fully automated algorithms. There's a human being in your underwriter who's actually making decisions about what the risk is and what that should look like and how that should influence your pricing. So I've had experience both in implementing algorithms where I just had to get them into an IT system, and then also implementing algorithms where I had to both get them into an IT system and get human beings, predominantly not deeply technically trained, to use them, understand them, believe them, and provide feedback on them. And in the new role that I'm in now, so I've been with Spencer Stewart for 7 or 8 months. So I'm new to the industry, obviously, so I'm trying to spend a lot of time learning about our space, our competitors, and kind of the human capital space more broadly. And we're looking to try to see how can we better leverage the data we have and the work we do with clients to actually help our clients more, to help the candidates that we put in front of clients better, to have more successful outcomes all the way around. So we're still figuring that out. So this is a function that didn't exist before I joined. So there's certainly some challenges and some learning curve for both myself and the organization about how do you actually start doing this with people that have no experience using analytics or consuming these sorts of algorithms. How do you actually start doing that? How do you find the right kinds of problems to solve? And how do you, in particular, find ones where you think you can actually have a positive impact on the business? So I will leave it at that, and then I'm looking forward to your questions and happy to have a discussion with you. So thank you.
Good evening to everybody. I mean, I'm the only non-tech guy here. Even though, I mean, I had a previous career, I mean, 8 years ago, prehistory, I mean, in CNRS, in theoretical computer science. So, I mean, I still have a background. It's very funny to see some of the ideas that we had 25 years ago coming to reality, just because, I mean, at that time we didn't have the computing power to make them real. So it's just somehow coming back to origins. What I want to present you is what we do in Renault since probably about 3 years. We created a subsidiary a bit more than 2 years ago, Renault Digital, to accelerate the digital transformation of the company. And I will be talking mainly about the impact on the organization rather than what we're doing in terms of technicity. What I want to point out is first the fact that AI, and when I'm talking about AI, is any kind of digital products that includes a minimum amount of machine learning. So it's not data visualization, it's just not managing data, it's really putting at least some machine learning, sometimes some deep learning, sometimes some augmented reality or some virtual reality in the product. If we start with engineering, obviously, looping back to engineering teams on the usage of the functions in the car is something that can be done now using data from connected vehicles that was not possible before. The probably main topic on the engineering side is all the autonomous vehicle functions that we're developing. If you want to test a function from an autonomous car in reality, you need to run it for about 10 million kilometers. This is not realistic, both in terms of cost and time to market. So we need to create scenarios and run them through different simulations and analyze the results and loop back to the definition of the function. So this is probably in engineering the most important investment. And anyway, I mean, using 3D simulation, 3D virtual reality, we try to go more and more towards virtual development phases to accelerate the development of the product. Industry 4.0 for the automotive industry, for Renault, but also for most of the, I would say, heavy industry is clearly one key part in terms of competitiveness, especially in the high-cost countries. So it goes through full parts vehicle traceability using IoT to be sure that we can optimize in a much more efficient way our inventories. Obviously, predictive maintenance on all kind of tools, robots, but also stamping press and all equipment within the plants. Supply chain optimization. And more and more use of virtual reality, both in terms of training of the operators, but also in detecting quality defects on the cars rather than using traditional quality control tools. Marketing and sales is more classical, obviously simulation about sales, customer clustering, offer personalization. Once again, virtual reality in terms of product discovery and using quite advanced 3D recognition and usage-based maintenance and insurance, so offering our customers maintenance programs and insurance policies that will be adapted to the way they drive and how they drive and where they drive. And finally, all the other functions are in somehow, some ways, touched by AI. Finance, clearly, full cost traceability simulation in a much more deep way. We're also using it to improve our employee digital journey customization. Generally, the tools that we were using for HR were quite old-fashioned and certainly not customized. So this is something that we want to concentrate on about. And including general services, creating digital twins of our buildings allows us to improve the maintenance, but also the energy consumption. So, in terms of impact on governance, what we realized in the past 2 years is first, you need to put on a specific governance at the COMEX level, to make them understand what's at stake, what will be the impact on the organization, and to take some time with them so that they understand not only what we can do in terms of, let's say, financial impact, but also the techniques that need to be used and the limitation of the tools that we can use. The second impact on governance is obviously that, you just don't use an AI product like this. It has to be done within a process AI interaction, a process modification, a rework of the process, and a rework of the organization. This is the only way to give full power to AI. And the third part is, as I said before, if you want to take the full power from AI products, you need to bring it as close as possible to the business and to the operation, which means that you need to empower the team in their usage of the product so they can take decisions at their level rather than use a traditional hierarchical model. So this is a path that Renault is taking. And this is definitely a direct impact of digitalization and AI use. On workforce, I stole a word from Luc Julia. At this stage, what we're using in Renault and what we're using in automotive industry and most industry, in my eyes, is not artificial intelligence. It's just augmented intelligence, in the sense that there is no fully automated process in terms of decision process. There is always a human AI interaction, and the human has always the last word. So this is quite important, and this is once again pointing at the empowerment of the employees and the empowerment of the teams. The second point that is extremely important is that it modifies deeply the ways of working. In terms of mastering, obviously, the impact of the AI, understanding what AI is about. It also forces the team to work together with AI specialists, data scientists. It's not, the products that we provide to the teams are not something that are done separately by a data scientist team and then just put for use by the users. It's really something that is co-developed between the data scientist teams and the users, and this forces us to put in place a significant program of upskilling and reskilling of the general population, managers, but also the people that will be using the tools, in order for them to be able not to be, I would say, the slaves of the products that they will be using, but really to understand what it's about. Potential hurdles. GDPR is something that we tackle with a privacy by design approach. So this is possible for new products. It's a lot more difficult for traditional IS systems that were not built for that. You have to understand, in the automotive industry, what we call the VIN, which is the identification number of a car, is considered as a personal information. This is used in, I would tend to say, probably 60% of the information system used by any car maker. Some of them are dating from 20, 25 years. So this is a stake for the whole of the automotive industry and Renault as well. Beyond that, ethics rules are something that we're building. It's true, obviously, for autonomous vehicles. It's true also for the use of AI throughout the company. And one key part, once again, is the fact that we never consider that we should automatize completely decision processes. I mean, we should have always human beings in the middle of the process. One key hurdle that we have to overcome is a black box effect. And this is coming not from the specialist teams, not from the data scientists. It's coming actually from the managers or the people working in the functions that are expecting some kind of magical black box from AI. And it takes quite a lot of time to explain to them that no, this is not a magical black box. This is something that they have to build with us so that they will be able to understand what is going on. It's very close to what has happened in the banking industry a few years ago. I had some good mathematicians, colleagues that were working on derivatives when it exploded. And it's exactly the same thing. We have to overcome the feeling from the managers that AI should simply provide a solution without understanding what's in it. And finally, management resistance. Management resistance is mainly linked with the team empowerment. This is something that we have to change in terms of culture. Data was traditionally considered as a key to power of the people within a company. Developing data and developing data governance and developing AI products is bringing data to the collaborators that need the information to take decisions. And this is something that is quite strong in terms of impact to the organization. I will be very happy to answer your question now. Thank you.
All right, so we will begin with a small brief discussion among the panelists, and then we'll open it up to questions from you. So to begin with, I guess the first question is, I guess I'll ask a couple of questions, and you can think about it as whoever volunteers decides to volunteer first. That's how we'll proceed. Is that okay? All right. So in general, I think I want to ask each of you, and especially those working in industry, do you see AI or robotics improving productivity? So that's the first question. What is your experience in doing that? The other question is, again, generally speaking, how do you see businesses misusing the power of this technology? Not intentionally necessarily, it's because there are poor organizational practices in play, there are poor incentives or poor regulations. So after that, more specific questions. The first one is for Bernard. So the question there is, Microsoft seems to be doing a lot. It seems to be checking all the right boxes in terms of trying to use this technology for its very, very best intentions. How do you see your competitors, do you find that it's necessary that other software solution providers do what you're doing? For instance, decide that if facial recognition technology is unethical, can lead to mass surveillance, forego the business opportunity there? Do you need them to act with you? If so, what is the conversation like with your competitors? Also a question for you. What kind of sort of stipulations or advice do you give to your customers that use the technology, the pre-trained algorithms that you are selling to a lot of different businesses? What kind of warnings or maybe even the bad experiences you've had? The next question for Bertrand is, so could you give us sort of a specific example of an industry approaching you, a business approaching you for a specific problem, and you giving it to an academic, whatever academic partner you decide, and you see things going well, things going badly, what are the demands and conditions, and related to the scikit, the open source, this is all open source, but then industry uses it, and that becomes a proprietary technology. A very good example is I do research and I publish it, but then those papers are behind paywalls and people can't read it. Something that a lot of academics themselves don't like. So what is your view of that? Megan, I would love to hear about the challenges that you had, both in just when you were just putting the algorithm into the IT versus interacting with humans. So one or two stories where you saw that go well versus you saw that go badly. And the questions I have for you is, will humans continue to have the last word? As you use human in the loop to basically train these algorithms, train the robots, do you see humans becoming obsolete and they're training their own obsolescence? And also I would love to hear more about the privacy by design that conform to GDPR rules. Some people have argued GDPR rules actually make European companies anti-competitive. But more generally, so you are collecting customer data. What are the privacy concerns that you have? How are you handling that? So with that, I let you decide who wants to talk first.
Can you refresh on the very first two questions?
Yeah, yes, I'm sorry. I have a written notes here while they don't. So the
second one was around how companies misuse.
Misuse
And
is.
what was the first?
Do you see actually productivity improvements? Do you see people being able to do either their work efficiently, or also do you see them being able to do more complex things that they weren't able to do before?
Okay, so I'll just give quick answers to both of those questions, and then my brain needs to reset again. So to the first one, around productivity. So the answer is, from my experience, is that it depends. So it depends on how you use it and how you set things up around it. So an example where it didn't work that way, one of the teams that I was managing, we were working with our business partners on a particular project, and it's a very iterative process, right? So we build a skeleton model, we talk with them, and we say, well, okay, there's 3 variables that are basically equivalent. Which one is the most intuitive to you, right? Those sorts of things. So we go around and around and around. Some of the work leading up to those meetings was very time intensive and fairly manual. So one of the people on the team said, I'm tired of doing this over and over again. I'm going to create a tool to automate some of this work, right? So great idea and concept. What actually happened is the tool worked really well, and the people around them said, oh, well, now if you can produce this in 30 minutes rather than in 3 days, we just quadrupled like the number of conversations. So it actually didn't improve productivity. It just meant there were 100 iterations rather than 10 iterations, and none of us were convinced that the actual outcome was improved by doing it 100 times versus 10 times. So I think the answer really depends on you can achieve productivity benefits, but only if you use the freed up time in ways that are sort of well thought through. To the misuse, absolutely, happens all the time, right? And to varying degrees. People, I think, your comments about people wanting a black box, right? They want some magic silver bullet that, I just want the answer, just hand it to me. The other part is that people generally don't actually want that, even though they say they do, because if you give them a magic black box that tells them the answer, they say, well, I've been doing this for 20, 30 years. I know, what does your black box know? I know this industry. I know this problem. So people, sometimes the problems they're articulating are not really the underlying issues that need to be addressed. So people misconstrue things all the time. They misinterpret. I think one of the probably biggest frustrations on the part of data science teams is that all the nuance of the analysis gets lost when you're presenting to like a C-suite team. They just say, well, how long is it going to take? How much is it going to cost me? How much is it going to benefit me? And nobody really cares about sort of the underlying story, right? I'm deliberately generalizing, right, and sort of making an extreme case. So I think there's education that has to happen both ways, right? Because I think data science teams also are often seen as ivory tower and elitist and unintelligible to anybody outside the team. And so I think there needs to be learning both ways. I think data science teams have to help educate their business partners on where are the really critical things that are in the nuance that they do need to understand, right? There's a lot of it that they probably don't, but there are sometimes 1 or 2 things that you really do need to understand and appreciate. And then on the flip side, we really rely quite heavily on our business partners to help educate us about how do we design solutions that are actually going to be useful to the business and that people will actually use. So hopefully that was concise.
I won't answer all the questions, but maybe on the misuse of data, of course, it's very hard. I think I will be I will kind of follow up on what you said, but it's very hard to control that an algorithm is not like discriminating people when taking a decision. So assume you are a bank and you are deciding whether you want to give a loan or not to people. So you would like the decision not to depend like on the ethnicity of the people or their backgrounds. But of course, there are lots of ways, even if you remove this information, if it were there by chance, well, there are some other ways to get this information, like when you know the address of the people or some information on them, you can infer this information, or you want to avoid biases related to gender, etc. And of course, you can guess the gender of somebody by many different means. So really ensuring that your system is free of biases, against people is super hard. It's not only removing the information that could be problematic, but it's sometimes even making sure that the decision taken by the algorithm does not have some latent information that can capture it. So I would say it's an open question currently. And okay, maybe.
Oh, come on. Please continue.
So you also asked me more particularly on our relationship with the industry, the kind of.
Could we hold off on that so that we can get the
sure.
questions to the general questions, and then we can come back to the specifics? Bernard.
So I'm going to give two quick comments on productivity first on the positive side, and misuse on the negative side. So about productivity, if you contemplate the number of security events we face every day, it's in the order of 6,500 billions of events per day, which means that there is no way to analyze those security events in order to understand if there is a threat somewhere. So we heavily rely on complete automatization of the security environment. We have no way around it. And it works very efficiently on millions and millions of servers. On the negative side and on potential misuse of technology and AI, perhaps you remember we announced about 3 years ago a bot named DATAIA. So this bot was in fact misused by the users and very quickly, in less than 36 hours, it started to give some pro-Nazi comments and all that. And in fact, what is very interesting in this story is we have already implemented 18 months ago the same bot in a different culture in China. This bot is currently probably the largest end-user bot in the world. It's named ChaiBot, and it is currently used by more than 150 million users every day. And in fact, we never had this problem in China, never. It was built exactly on the same principles, but it was implemented in a different culture, and it failed miserably in the US, and it is still up and running in China without any problem. So we had to change and implement a different way of handling the various questions and answers that the bot was supposed to give to the users, knowing their context, their culture, and all that. But it was a really bad experience for us because, in fact, we tried to transfer the technology from one culture to the other one, and it failed.
Productivity, yes, definitely on things first that we cannot do by human means. The example I gave about autonomous vehicle is one. I mean, it's just not realistic to think that you can do it in real life. So I mean, it's not even productivity; it's just making it possible. It's probably quite true also in terms of productivity in all manufacturing and supply chain. This is very simple, and the algorithms are quite, I would say, robust. I would probably tend to say that on the marketing and sales side, it's much more an open question or a question mark, or sometimes a very misleading use of AI, simply because, well, especially in the automotive industry, you don't buy a car every day. So the number of events that we have, and the time sequences that we have, are simply not big enough to train your models very accurately. And using typically AI for predictive models is, at this stage, and this is not only for Renault, and this is the will of the automotive industry, not so convincing. So we spend a lot of time, we spend quite a lot of money on this. We're not the only one, but all the results are so-so, I would tend to say. So it really depends on some basic principles. You need to have enough data. You need to have time sequences that are rich enough. And if you want to start skewing it and using it in cases where events are just too scarce, you end up with stupid models.
Thank you. And so do you want me to repeat specific questions maybe, or do you... But you, sure, yeah. Yes.
At least partly. One example is, so one researcher of my team left us 8 years ago to create a startup on medical imaging to do some fancy medical image visualization. And then a few years later, they realized that the big thing now was to use deep learning to improve the analysis of medical images. And so they came back to us because we are machine learning specialists, and so they asked us to do some consulting with them to create their deep learning system to identify tumors in mammographies. So this is what they are doing several applications. This is one of them. And so radiology in general is a field where AI can be super useful because you need to identify tumors in images, but so an artificial system can learn from tens of thousands of scans. So all this learning can be automated and be very efficient. And this is certainly a case where AI and deep learning can help become quickly as good as a human expert, and sometimes even better. And actually, with our help, they could build a system. They won a competition on mammography. So it's Terapixel, the startup. And well, with that now, they are even better than experts of the domain to identify tumors in mammographies. So typical examples where a relatively short collaboration between an academic lab and a startup can have a pretty strong impact.
So where did the data come from for training, basically, these machine learning algorithms?
In that case, so there was some publicly available data, and there are fields in which you have data available, and then there's a big progress with machine learning and AI and data science, because once you have data, you can really gain something. There are complete fields that do not have public data. In medical images, for instance, some type of images do not have public data sets, and then there is no improvement. We are still at the level where we were 10 years ago. So in this particular case of mammographies, there were publicly available data, and what they did is something that is very frequent now, is to do data augmentation. So you tweak a little bit the data, you perturb it, and still you can use it, you input it to your model, so you generate more data, you bootstrap on the data to get more, and this helps improving your classifier.
So I can't help going back to my example in the introduction where DeepMind uses retinals, has been able to identify retinal disease using retinal scans. Yep. But that data comes from UK citizens, and DeepMind accessed that data without their consent. And it was in hot water for that for a while. So do you have that same concern in this application for mammography? You are claiming it's a publicly available data, but did the people know that it was their data that was being accessed?
Yes, of course, and especially if you do that in France, you've got the CNIL, etc. So it's pretty tough to when you play with medical data. So actually, in my daily research, I do share medical data with the agreement of CNIL, so with informed consent by the participants, etc. So I know well these ethics processes, and yes, they are essential. We need to protect people. People should agree with the use that we do with what we do with their data.
Okay.
Well, I can jump in on. Do we train? Do our collaborators are just training programs to be replaced by the program? Frankly, no, I don't believe it. I think this is exactly what I was saying about augmented intelligence rather than artificial intelligence. We are very far from thinking of replacing the actors. Our goal, and this is what we see for at least the next 3, 4, 5 years, is really to bring help, to bring support, and to the actors rather than replacing them. Maybe I'm idealist, but this is anyway the way we develop the programs and the way we organize the company around AI. On the second question on privacy by design, what obviously we do systematically is, first, ask the consent of our users on the use of personal data. This is done now systematically, and it's easier, obviously, when you're developing new products rather than using all the IS systems. We do systematically use either anonymization or pseudonymization of the data when we develop algorithm. And we try systematically to have a clear governance on the way the products are developed. All the ISIT organization has DPOs by sectors. I have a DPO in Renault Digital that is in charge of making sure that data privacy is respected. So once again, I think the main two stakes are, first, it's easy to do it on new products. It's a lot more difficult to clean all the IT systems. And this is something that will take time for the industry. The other difficulty in GDPR application is not protection of privacy, is portability of the personal data. Because, at this stage, if we were to give all the personal data back to our customers, once again, it would be very easy on personal data. It would be a lot more difficult when it comes to the description of the vehicles that they're using, because this is ingrained in all IS system and information systems that a company is using. So, we do it when we develop, and we have a lot of cleanup to do.
So the question for me was around developing algorithms that are more automated versus developing algorithms that go into the hands of human end users. So in some ways, there's a lot of similarities, because even when you're developing algorithms that are automated, there are still people that you need to convince about what you're doing, right, in some way. So when I worked in the insurance industry and we were developing, these pricing algorithms that run without any sort of human intervention, we still had to file information about those algorithms with every state Department of Insurance in the United States. And the people that work in those departments and that review and authorize you whether or not you can use these algorithms are predominantly non-technically trained people. They're mostly lawyers by background. So you have to convince them that what you're doing meets all the regulations, is fair, that you aren't sort of price gouging people or things like that. And you have to be able to explain it to them in ways that they can understand so that they feel like they've done their due diligence, right, in protecting the consumers of that state. So even though the algorithms are automated, there's a whole lot of work that goes in before they actually start being used, where they have to go by, you know, obviously lots of people internally, because you don't like to show something into the state that the state then tells you you can't use, right? Insurance companies try to avoid that. So there's a lot of internal conversation, and then there's the actual formal regulatory process as well. So in some ways there's similarities. It's just a little bit, there are differences. So some of the differences are when you're developing an algorithm that some person is going to receive the output and they have to make a decision, there's far more change management involved in that, right? Because you're, by definition, by providing that information, you want them to do something with it, and you want them to do something differently than they would have done if they hadn't been provided the information, right? So you're looking for a behavior change, a different reflection at minimum on a decision, right? Or actually starting to synthesize and incorporate additional information or different information. So that's far more challenging, and so every time you implement a new algorithm, there's still a change management piece. That is bigger in many ways because you have hundreds or thousands or, you know, something end users, where at least in the more automated algorithms, you have 50 state regulators, but they're used to the process, right? They know, you know, kind of the kinds of algorithms that are developed don't drastically change year to year, and so it's a little bit easier because you're sort of going back to the same, many times the exact same individual, right, or at least the same department, where there's some more foundational, sort of shared foundational education on both sides. So the change management is usually a little bit easier there, right? It's a little bit more standardized. It's a much bigger picture thing when you're deploying to many end users.
Bernard.
So if I remember well, I had a question related to max of competition.
Yes.
And what we do around trying to be better on everything related to data, privacy, ethics, and all that. I think somewhere it relates to what our business model is. We're not selling our customers' data. We're not making use of this set of data in any way, which means that customer data belongs to our customers. So that's very simple. And it implies that, as an example, we are not training our models based on our customers' data if they don't allow us to do so. So it's relatively easy to both comply with the law, beyond the fact that you were mentioning that it costs a lot to update all legacy systems in order to be GDPR compliant, as an example. We've spent $500 million just to be GDPR compliant on our old systems. So it costs a lot, for sure. So privacy by design is something which is more easy to do, especially because it is some solutions are currently starting to be available. I mean, homomorphic encryption, as an example, is starting to be real. We have just released a complete homomorphic encryption library in order to be able to use health data record in such a way that no content is shared to potential third party. The goal being to use multi-party machine learning algorithm where you are able to share data with different parties without any of those parties facing the risk of this data to be shared with other parties. Differential privacy is something on which we have been working since at least 15 years. So it is usable. And there are also some harder solutions like what has been designed by Intel, which named SGX, where you are able to create enclave inside memory, where everything coming in is encrypted, which means that from all the data and instruction which comes to a processor, everything is encrypted. So the end result is also encrypted, which means that only the CPU is able to see the data in clear. So there are some solutions which are currently starting to be available on the technology side in order to solve this kind of problem. So to give you a very simple answer to your question about how we deal with this privacy and all the ethics concerns and all that, I think it relates to our business models. And you had a second question, which I don't remember.
So I think I want to ask that question, but I also want to give the audience a chance. So if you don't mind, I want to...
No problem. I will
up.
skip my answer because I don't know the question. So
if we can, we
very
will come
easy
back
for
to
me
it.
to do it.
We'll come back to it if we have time. But I want the audience members to bring up their questions. And you can just raise your hand. You can sit at your place and just... so we have a question right at the back. Can you hear me? Yes. You're right.
This is microphone. Okay, great. Well, Luc Monté, I'm executive MBA here and I work in the energy domain. I would like to raise a question of the environmental footprint of AI. On one side, we got a human brain consuming 20 watts. On the other side, we have software trained for long years and running on hardware of maybe several kilowatts. So I would like to have your feedback on that point.
So I'll just give a very short. So when you ask that question, the thing that jumps to mind is blockchain. I would really love someone, please, someone explain to me why that's better than other solutions. Right, I get that existing ledger systems have issues, but blockchain confuses me so much. Right, and I think the costs are really, really high, right, at least for the proof of work sort of structure. So one of the things I've seen, at least in how people develop algorithms, so when I first started my career, I wrote highly inefficient code because I didn't need to write efficient code. But if you tell people they have to write efficient code, it will be efficient, right? If there's some constraints around the problem, people will figure it out, right? And I think edge analytics is an area like that, where you have to have highly efficient code because of you're trying to make decisions so incredibly fast. You can't waste time with a few extra characters. So I think, I don't know that there's a lot of people doing analytics that really appreciate where you're coming from. So it's probably something that needs more education and then some more guidance to people around why is that important and to actually teach them how to write better code. Because there's probably a lot you could save, not by changing how much we use algorithms, but by actually designing the algorithms to be more efficient. Some of that happens naturally when you embed in corporate IT systems because everything just costs more if it takes more processing time, right, all the way around. It takes longer to develop it and implement it. It takes longer to test it. It takes longer to maintain it, blah, 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 right? It just costs more. So you get some reduction there, but it's probably not as efficient as it could be if that was an actual outcome that was sort of highlighted to people. So for what that's worth.
So just to add on that, it's clear that human brain is much more efficient than the most advanced AI algorithm for sure. Beyond that, I think there are some solutions which are currently being implemented in some very, very limited CPU power and memory available, like on Raspberry Pi processors, where, as an example, you take a deep neural net with a lot of layers in order to do facial recognition, as an example. And you want to implement this algorithm in just a camera at the front door, where you just want to recognize a set of 10 people who usually open the door and are allowed to do so. In order to do so, you can, and this is something on which we have written a paper about 3 to 4 years ago, you cut the end layers of the neural nets and replace those layers by some very easy to implement algorithm like nearest neighbors as an example. And it helps you to save a lot of power, a lot of CPU needs, and a lot of memory consumption. So there are ways without using the entire model with all the layers in order to save a lot of energy and CPU consumption. So there are solutions, technical solutions to this. But as you mentioned, you need to be constrained in order to implement those. Otherwise, you have thousands and thousands of GPUs or FPGAs or ASICs available in the cloud. You can consume like energy, having the illusion that this energy comes for free, and you can get as CPU as you need, as much as CPU as you need. But in fact, when you are constrained, you are able to do so, potentially by this changing a little bit the way you approach the problem, but there are solutions to it.
I fully agree with that. So with two small additions, so in the coming years, you will have more and more dedicated architectures that are no longer generalists. So they can do a particular task, and they are more efficient than to do this particular task. So this will be probably one solution. And I think following what you said, so you can also thin some deep networks, which are very, very heavy architectures. But we have some researchers have shown recently that you can drop essentially 99% of the artificial neurons of the network and still get a solution which is as good. So once it has been trained, you can sparsify, the technical word for that, the network, and so make it much lighter. So it will be also a solution to still be able to do very complex tasks with architectures, but with more modest power.
There's a question at the back.
Thank you. My name is Rong Hui. I'm from the MBA program. I actually have two questions. The first question is actually so AI is like innovative and it's changing the way organizations work. In what areas do big companies choose to collaborate with startups sort of to implement AI solutions, and in what areas do they kind of like look to do it themselves? And the second question is kind of related also to the first, which is it seems to so from the way I understand the AI industry, so companies like Google, or organizations like Google, DATAIA Institute, you build like kind of the fundamental layer on which other people then build the applications on. Sort of, but a lot of the applications that people are building in energy space, in say translation or other spaces, they seem all kind of pretty similar. So a lot of startups that are coming out of these things are very similar. And do you see kind of like the startup space for AI, kind of application space becoming commoditized very soon, or yeah, like kind of fragmented? Thank you.
I'll try to answer your first question on collaboration with startups. Well, there is actually no real sectors that we will protect from collaboration with startups. We're working with some startups on autonomous vehicles, definitely on Industry 4.0. And marketing and sales. So there is no exclusion. There is one rule, though, is that we're making sure that the startups are not simply providing a new packaging of open source code, which is unfortunately quite often the case. And this is something that we probably need to work with the ecosystem, so that it's not breaking down the trust between large companies and the startup ecosystem. But as a principle, there is no exclusion. as long as they bring a good idea, a good code, or good components. Typically, I mean, to give you a specific example, I mean, we're currently developing a mobility service platform, mobility as a service platform. And our only task will be to provide the platform integrating a number of different services. I mean, all the different services will be provided by startups. We're not developing most of the services that we will be starting with are developed by startups.
So from my experience in terms of where the collaborations happen and where they don't, so the short answer is it depends. And it depends, at least in my experience, on a few dimensions. So one is the culture of the organization. So having come from insurance, which is a highly risk-averse industry, there was most of the insurance companies I worked at really had very narrow places where they wanted to partner with startups. They were afraid that if they used their solutions too much, the startup would fail, and then they'd have this gap that they'd have to suddenly fill in. They were concerned about how much of their own data they were sharing, right? There were lots of reasons around why. Other insurance companies I worked at, there was much more openness to collaboration and to working with startups. From a data and analytics perspective, the two sort of areas that I look at when I'm looking at startups, both when I did it in insurance and now that I'm doing it in the recruiting space, so the two key areas are around data aggregation, right? Because there's tons of external data sources. I don't have the bandwidth to compile and synthesize 60 external data sources and get other things done. So if I can partner with somebody who can help do some of that for me, then it's kind of a win-win on both sides. The other area is around capabilities that I am not going to be able to build in-house or that I don't want to build in-house. So for example, I was telling the panel earlier today, the team today at Spencer Stuart for data and analytics is me, myself, and I. And I'm in the process, right, I will have one more person joining in a few weeks. But for example, if we want to do things around natural language processing, right, which there's a bunch of use cases where that would make sense, the organizations that build their own proprietary natural language processing algorithms have teams of 30, 40, 50 people doing nothing but NLP. No one is going to let me hire 40 people to do NLP, much less hire 40 people. So we're going to partner for some of those solutions, right? So for capabilities that we are either unable to, right? It makes no sense for us to try to do it. It's just makes more sense to partner. Or for capabilities where we choose to use someone else's solution. It's either far more mature or makes things easier for us, or the business case around the cost benefit is just sort of obvious. But those are primarily the two lenses that I look at. And then I also look a bit at some of the automation pieces. But similarly, I think there's a lot of companies out there that they don't actually have a real deep technical product. They have really slick selling materials and a great story. But when you start digging on the technical questions, you find that the whole thing sort of falls apart.
Just to add on that, we as a company are helping a lot startups, and in fact, in 10 years just in France, we have helped 3,500 startups just to get funds, to get some help on how they should position their products. Because our goal is not to benefit from the work the startup is doing per se. We are working on making sure that our ecosystem is growing. So that our goal is not to work with the startup for what they are currently developing. Usually we don't have the need for their IP to be integrated in our environment, but our goal is to make sure that our ecosystem is growing. So that's not exactly the same goal as another company who is trying to get help from the startup to fix a specific kind of problem. We don't have the same kind of issue. We have enough means to do our R&D effort ourselves, usually. But coming back to your question about creating a startup to do natural language processing or do translation as an example, what is very hard for any startup is to get enough data. Because usually all those models are based on supervised learning, which means that you need to have enough conversation, as an example, to be able to train your models. And when you don't have enough data and get access to this data, either you have enough budget to pay some mechanical Turk in order to label your data, otherwise you're dead. You cannot have enough data to train our model, except if you are specialized on a very specific domain, like I want to be able to implement an insurance bot. So the number of words you have to recognize is limited enough to develop bots with all the NLP-related algorithm to be efficient. But if you want to touch a very global domain, like being able to sustain a conversation with anybody in the street, that's not exactly the same goal, and that's very difficult to accomplish without having access to enough data.
There's a question there. Oh, I think you need to say the question into the mic.
Sorry. So my question would be to all of you. Are you doing something in the field of translation from difficult or complex information to read to something too easy to read or to understand? Because it could be documents which are concerned, but also videos, for example. So are you doing something, and if so, what?
Yes, this is a topic on which we are working a lot. So translation is something which has gone through a lot of progress recently because we have moved from a statistical model to neural net, and it has helped us to improve a lot the quality of our translation. So in order to be able to translate, you first have to understand what the person is talking about. So you need to understand any word, the entire sentence. You need to be able to understand very precisely. So there is this automatic speech recognition phase in the model where you need to go through in order first to understand in the first language what has been said. Then you need to go through this translation process and potentially to synthesize using a text-to-speech approach in order to be able to speak to the other person in its own language. So that's usually hard, but there has been some very good progress recently on this, even on very specific topics. But if you want to train, as an example, a doctor to be able to speak from French to German or German to Chinese, it is a very specific domain where you need to understand very precisely all the words that are being pronounced on a very specific domain. So that's a topic on which you need more data if you want to be more efficient. So it's not exactly the same as creating an assistant like Alexa or Google Home or whatever to be able to choose your playlists on your favorites music player. It's completely different to train a model in order to understand this kind of language. So perhaps there is a need on specific domains to develop specific approach in order to better understand how a doctor is able to write the report of a specific operation or a specific analysis. So, but usually the translation is good provided that you have enough data. So there is a direct link between the quality and the amount of data that has been used in order to train the model and the quality of the model itself.
What does enough data mean then?
So I will be, if you want to translate a general purpose language on general purpose topics, you need multiple million of hours in order to do a good training. And you need to get labeled data for those million of hours. That gives you an idea of the amount of data that is needed in order to do good translation from one language to the other one.
And even if you do a translation, a simplification of the language from the same language into the same language?
If you simplify the language, you will need less training data. I'm talking about being able to do general language recognition from one language to the other one. So if there is a very specific domain where there are 500 words, as an example, you need to recognize, it is not the exact difficulty of being able to translate any conversation like the conversation we are currently having, knowing that in order to be able to recognize a language, you need to get rid of the impact of the noise. As an example, in this room, there might be some conversation in the room which might interfere with the language you are trying to recognize. So you need to have a model which is able to filter the noise from the outside world, and that's not something very easy to do.
There is a question there.
Yes, so I have a question about the, since we are in the business school, and you mentioned a lot about sort of technologies, many of them are very complex, but kind of to train the managers that will work in companies, that will work with people who are data scientists, what kind of skills should we be teaching, or what type of skills should be managers already working in organizations be acquiring in order to benefit from those technologies?
So I guess my thought would be probably the most important things are an openness to learning new things, and an ability to modify how you do things over time, right? If I think about it, because it's certainly not like learn a specific programming language or something like that, right? I think it's more where I see the most resistance is in people who have no interest in trying to understand at all, for all sorts of reasons, right? And then some people are interested in learning and maybe even learn some of it, but they have a very difficult time changing the way that they do things to accommodate the new information. Those are also really hard skills to teach.
Yeah, I fully agree. I mean, I would add one thing is accept to test and learn. Accept to fail, accept and look for fast failures rather than try to stabilize at all costs, I mean, the process that they're using and the way they work. This is generally, I mean, where we see resistance in our company is people that are so ingrained in the way they've been working and so ingrained the way they've been functioning with their teams, that the idea of, I mean, changing it and testing new things and accepting that, I mean, most probably it will fail the first few times is quite difficult. It's related with openness, obviously.
There is an excellent book you can potentially read. It is called Growth Mindset. I don't know exactly what is the correct translation because I think the French version also exists. And this is the opposition between growth mindset and fixed mindset. When you have a fixed mindset, you are supposed to know everything. You cannot learn anything new. You are supposed to have all the answers to all the questions. So evolving to a growth mindset means that you are able to learn, you are able to fail, and that's a completely different way of managing the organization. You also need to have an approach where there is not the standard manager knowing all position. You need to have a more horizontal organization. And as an example, we in Microsoft have taken the decision something like 5 years ago within our engineering organization to have a manager-free organization where engineering teams, feature teams in our development environments are not managed by managers. They are self-managing themselves. And that's a completely different approach, which means that at the end of the day, we changed our recognition process where you success as a team or you fail as a team, not as an individual. And it has changed completely the way our engineering teams are working together.
Something I see with students, so different students from engineering school like Polytechnique, Centrale. So they have changed a lot in the recent years. Now they are much more efficient, so they can do things very, very quickly. You could just ask them to do something with machine learning, deep learning, and they do it faster than me. Well, I'm amazed because this was really not the case a few years ago. I think now what they need to learn more is skepticism. Well, you know, you will have lots of authoritative arguments, or the system says that. Well, but the system may also fail. So we have to understand the failure mode of the system that we use. So, well, skepticism.
Hi. My question is, in your opinion, is it ethical and sustainable to use non-explainable algorithm with black box in fields such as health, insurance, or human resources?
Probably not. Probably not. So it's not exactly the same thing to use a deep neural net in order to recognize a cat or a dog and to take a decision to give a specific price for an insurance contract, or potentially to give you access to a specific engineering school, like what was done in France recently without any AI, but with a completely black box approach to choose any student to be admitted in a specific university or engineering school, as an example. So I think there is a need for the algorithm to be explainable. Explainable doesn't mean that it has to be completely transparent. I mean, you have to read any line of code and to be able to understand what has been exactly coded in those lines, but to be explainable in such a way that any human being is able to understand it, which is not an easy task, especially for deep neural nets, which are usually not very easy to understand and potentially to explain. So at a certain level, you need to take a trade-off between the quality of the algorithm and the fact that you are able to predict with a very low false positive rate, as an example, what you're supposed to predict, and the fact you are using a much simpler algorithm, but being able to get a correct result, completely explainable. So that's my personal view on that. But this is a topic which is currently very, very active in research. So I'm optimistic in the fact that we'll be able to find a way to explain even very hard to understand deep neural net in the future.
Yeah, I agree with that.
That would be the last comment, because I'm keeping an eye on the clock.
So one of the aspects, okay, you are using black box all the day. I mean, when you go to the radiologist and, well, the radiologist himself doesn't know how everything works. You know, he uses stuff that just works. So as soon as, you know, you have some correct benchmarks, that you know that the system is working under the conditions where it should work, well, you trust it because you have to. You cannot, you know, probably don't understand everything in a car, I believe. Even if, you know, having safe cars is super important, you cannot maybe understand every detail in the car. So yes, to some extent, in medical technology, you will have more and more black boxes that tell you where the tumor is in the image, and this is great because it will save a lot of time and it will be probably more reliable than human annotations. So in those cases, you want to use sometimes black boxes. And at the same time, I agree that whenever you can, having some simpler systems is beneficial. And there's lots of research ongoing on the interpretability and the study of the robustness of AI in general.
So I can't resist, so I will ask one question following up on the black box, is that it's not just a matter, as a social scientist, when we think about using machine learning, we often cannot, our problem is we can't make any causal inference, and that is problematic. But the other problem is if you are selling something like Azure, and it's been trained on the data that is proprietary to you, which you're taking measures to encrypt, then do you give them caveats about this is the kind of data it was trained on, so the inferences you're going to make is limited to the inference, to the data. So those are two sort of concerns. You can't make a causal inference. You don't know what are, in some sense, what is the training data? What are the limits of that training data?
So just it's very, most of the time you're not making a causal inference. And again, I think it comes back to some of the trade-offs people are talking through, right? So take your car insurance. The primary variables in your car insurance, there are some regulatory differences. Your age, your gender, what kind of car you drive, where your car is garaged, in the US, your credit score, and your past driving behavior. How many of those do you think are really like causal? Right? I mean, your past driving behavior, maybe. But the rest is not. They're all proxies because it's the best we have. We don't have, right, up until the rise of telematics, but it's still not that prevalent. You don't have actual driving behavior, so you have to use something else. The alternative is that you don't. You don't create algorithms and everybody pays a flat price, but most people aren't okay with that. Now, on the flip side, I personally might not choose to use telematics because I don't want the data collection, and I, as a consumer, am willing to, I know that will eventually mean I will pay more, and I'm comfortable with that as a consumer. But those are the kinds of trade-offs you're making, and they're not causal. We don't, but it's sort of these large volumes of data, you prove it out time and time again, and you say, there's a correlation here that is strong enough, right, and then you monitor that and so on. But most of the time, you're not actually making causal. And it's very, very difficult to do causal. Your second question was on my jet lag. It's just...
And my habit of asking multiple questions. I myself have actually forgotten the question I was asking.
If anybody else wanted to answer.
I guess the limits of the training data. How do you caution people that this was trained on this data, which obviously we are not going to share with you. We have measures to protect it. But the inferences you're going to make, even the correlational one, have limits because of the training data.
Yeah, so it's hard. You can tell people, which you do, And then sometimes people understand and listen and behave differently because of it, and other times people don't, and so sometimes you have to go back again and again. You know, I've seen this in places where you're trying to do something, your model was built around a particular segment of the population, and so that's where it's really valid, and then it gets fuzzy around the edges of that population. And so if somebody wants to start a marketing campaign to move into a new segment of the population, then you try to have a lot of conversations with them around, like, let's be careful, let's pilot, let's go slowly, let's monitor a lot, right? Because we don't have enough data to give you something better. So it's going to be, you know, very highly educated guesses, right? But try to put some boundaries in place to allow you to protect against, you know, really adverse outcomes. But there's no perfect answer to that, right? It's a continual conversation.
Okay.
Maybe just one word on causal inference. It's also a topic we are looking at, because when you use data science and machine learning, typically for sciences, like you want to discover processes, so you need to not only, you know, discover indirect effect, but you would like to discover, if possible, direct effect, at least from the set of variables that you were able to observe. So there's lots of work going on currently on how to make a reliable inference. And of course, it's super important when it goes to health sciences and biology, because you want to discover the true effect of molecules, like on your health, etc. So this is improving. And so regarding your second question, yes, of course, when you've got some, technically we call that distribution shifts, where your test situation is different from the training situation, and yes, the algorithm will fail. But on the other hand, it's very hard to give the user an account of what data were used to train the model, because it might be huge. So I don't know the solution to that, how to efficiently warn people against this.
I think this should be part of some kind of general culture, because AI is playing a new role in our society, and we need to make sure that all citizens have a certain knowledge about it. Otherwise, it's like black magic, not black box, but black magic. So coming back to this inference and causality versus correlation, there are a lot of research topics ongoing on this, especially using a part of probability which is based on Bayesian inferences, which looks to be very promising. So it's an old part of the statistics which has been a little bit left aside from the AI field, but it is now restarting again, which is always the same when you do scientific work. Some areas look to be very fancy at one time and not so fancy the time after. So you need to change your mind and to be open and to be ready to learn and growth mindset and all that.
All right. And on that note, thank you very much to our panelists. Thank you very much to all of you for being here, for listening attentively and asking interesting questions. I have thoroughly enjoyed this, and I have thoroughly enjoyed preparing for this conference. I would like to thank particularly my team, Benedict, Lohian, Paul-Marie, Sang-Sok, Jean-Remy, who have been really helpful in organizing this conference. But we would particularly like to thank Elizabeth Desreals, without whom none of this conference would be possible. So as a gesture of our thank you, we have this flower for you. And I hope you all have a safe drive home and have a good week ahead. Thanks again for being here.